actually on this plane. The point 2, 6, negative 5 is on the plane. Any point on the line between these two is on the plane. The point 4, negative 9, 2 is on the plane, as well as any point on the line between these two. So basically, I'm pointing out that you have lots of options for a point. Why don't we use 0, 0, 0, and then let's use one of the other ones to convince ourselves that we get the same equation, we get equivalent equations, no matter what point you pick. Just make sure you pick a point that is on your plane. The reason why I know that the origin is on the plane is because those vectors are assumed, because I wasn't told otherwise, that the origin is the initial point of the vector. And so if my vector goes from the origin to that terminal point, the origin has to be on my plane. So we then take the component of the normal vector, and then x minus the x coordinate of your point. In this case it's 0, so I really don't have to. And then the y component, y minus the y of your point, and then z minus. Again, that's the mechanics. What you're actually doing is you're finding the dot product between your normal vector dotted with a vector you know is in the plane. And because the normal vector is perpendicular to the plane, we know that that dot product should be 0. That's the logic we're using to form the equation. So then step 3 is kind of to put it together, so we would have negative 33x minus 24y minus 42z equals 0. Probably I would multiply both sides by negative 1. I would think your book probably would do the same thing. Okay, so there's the equation of that plane. All three of those numbers are divisible by 3. And so 11x plus 8y plus 14z is equivalent. These are equivalent equations. Okay, so just be aware that, you know, you can multiply or divide both sides of the equation and get an equation that's equivalent to it. Yes, these are this one.
No.
You're just saying, okay. All right, if we use one of our other points, so if I use 2, 6, negative 5, we would have negative 33x minus 2 minus 24y minus 6 minus 42z plus 5. And that would give me negative 33x plus 66 minus 24y plus 144, right? And then 210. So I still have my negative 33x and my minus 24y and my minus 42z. 66 and 144 add up to 210, don't they? So the negative 210 and those cancel out. So notice I got the same thing whether I used the point 0, 0, 0 or whether I used another point that I know is on the plane. By the time you clean it up, you get the same result. Again, your textbook probably would multiply both sides by negative 1/3. Hey,